This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 3 of Week 4. Impeller types and specific speed. A short, low-yield topic, so we'll keep it tight. Specific speed bundles a pump's speed, flow, and head into one number that tells you which impeller geometry fits. Radial, mixed flow, or axial. It's a selection guide, not a performance prediction. And the unit's convention is the only real trap. What specific speed is? It collapses three operating quantities, rotational speed, flow, and head, into one number, characterizing the best-suited impeller geometry. N is the speed in RPM. Q, the flow at the best efficiency point. H, the head per stage there. The key insight? Two pumps with the same specific speed are geometrically similar in their flow path, regardless of size. It's a shape fingerprint, not a size or a power. Always evaluated at the best efficiency point and per stage, or the number is meaningless. Read the geometry straight off the formula. Head sits in the denominator, so big head pushes specific speed down. High head, low flow duties give low specific speed, calling for radial impellers. Flow sits in the numerator, so big flow pushes it up. High flow, low head duties give high specific speed, calling for axial impellers. Mixed flow fills the middle. Physically, a radial impeller flings fluid outward to build head, while an axial impeller acts like a propeller, moving a large volume with little head rise. The selection bands, using the US form with RPM, GPM, and feet. Roughly 500 to 2000 wants a radial centrifugal impeller, high head, low flow. 2000 to 5000 a Francis mixed flow, medium head, medium flow. 5000 to 15,000 an axial propeller, low head, high flow. These bands are approximate and vary by reference, so treat them as a selection guide, not an exact cutoff. And they're the US convention. They won't match an SI form specific speed. The real trap. Specific speed is convention dependent. The formula isn't dimensionless, so its value depends entirely on the units you feed it. The US form uses RPM, GPM, and feet. That's what the bands belong to. The SI form uses cubic meters per second and meters. Same physics, but numbers orders of magnitude smaller. And a third, truly dimensionless form uses angular velocity in radians per second, different again. So a bare specific speed of 2,500 means nothing until you know it's the US form. Quoting a US number against an SI band is the classic error. On the exam, the US convention dominates. So convert flow to GPM and head to feet first. Worked problem. A single-stage pump at its best efficiency point, 1,750 RPM, 1,200 GPM, 80 feet of head. Compute the US specific speed and select the impeller. The plan: apply the formula in RPM, GPM, and feet. Evaluate the square root of flow and the head to the 3/4 power separately. Then combine, and drop the result onto the bands. Crunch it. The square root of 1200 is about 34.6. 80 to the 3/4 power is about 26.75. Combine and the specific speed is about 2,260. Just inside the 2,000 to 5,000 band, so a Francis mixed flow impeller. It sits near the radial mixed boundary, so a radial could also serve. The edge is soft. Report about 2,300. One caution: the head term is to the 3/4 power, not the 1/2. 3 ways specific speed goes wrong. 1. Mixing unit conventions. The bands are US only, so computing an SI and reading against a US band picks the wrong impeller. 2. Treating specific speed as a performance number. It's a selection index for the impeller family, not efficiency, head, or power. 3. Wrong exponent or off-design inputs. The head exponent is 3/4, not 1/2, and the flow and head must be best efficiency point, per stage values. A reality check. Common water pumps land between 500 and 15,000 in the US form. If yours comes out 30 or 200,000, recompute. Bookmark the centrifugal pump characteristics page where the specific speed formula lives. Specific speed equals N times the square root of Q over H to the 3/4, US form. The bands: roughly 500 to 2000 radial, 2000 to 5000 mixed flow, 5000 to 15,000 axial. Read the formula rather than a table. Head in the denominator means radial. Flow in the numerator means axial. Always best efficiency point, per stage, one consistent convention. It's a selection guide, never a performance number. Low yield, one clean pass covers essentially every PE question here. Specific speed told you which impeller family fits a duty. Next, we put a real pump to work. Topic 4 takes the manufacturer's head versus flow curve, crosses it with the system curve, and finds the operating point, the most tested idea in the whole pump block. Carry forward the best efficiency point habit. The operating point is where you check whether the pump runs near it. See you in topic 4.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.